The International Space Station, or ISS, is a remarkable achievement. It symbolizes human ingenuity and international cooperation. The story begins in a time of political tensions. During the Cold War, the United States and the Soviet Union were engaged in an intense space race. In the 1980s, the US proposed the idea of a space station called Freedom. However, the project faced numerous setbacks. These were mainly budgetary constraints and technical obstacles. Meanwhile, the Soviet Union had its own space station, Mir. With the fall of the Berlin Wall in 1989, the political climate changed. The US recognized the limitations of a solo mission and sought collaboration with international partners. Russia, with its experience with Mir, became a key player. In 1993, the ISS project was officially launched. This marked a new era of cooperation in space exploration. From the beginning, the ISS was more than just a scientific project. It was a symbol of unity and a shared ambition for the future of humanity in space. The International Space Station is a marvel of engineering. It's the largest human-made object in space, visible to the naked eye from Earth. Assembling this massive structure in space was a significant achievement. It took over 30 missions and countless hours of spacewalks. The ISS has a modular design, like a giant Lego set with various parts added over time. It mainly consists of pressurized modules that serve as living spaces, laboratories, and docking ports. These modules come in different shapes and sizes. Each module has a specific purpose. The American modules house life support systems and laboratories for scientific experiments. The Russian segment provides propulsion and keeps the station in orbit. Other modules, like the Japanese Kibo and the European Columbus, enhance the station's scientific capabilities. The solar panels, extending like giant wings, supply power to the station. The station's robotic arm, Canadarm2, assists with maintenance and captures visiting spacecraft. The International Space Station isn't just built to be a spectacle, it serves a crucial purpose, acting as a springboard for humanity's future in space. It's a unique laboratory in constant free fall around the Earth. This creates an environment that can't be replicated on Earth. The primary goal of the ISS is scientific research and discovery. The experiments conducted on the ISS cover a wide range of fields, from biology and physics to astronomy and materials science. Scientists use the microgravity environment to study things like crystal growth, fluid dynamics, and the effects of space on the human body. The ISS also serves as a testing ground for technologies needed for future space exploration. Life support systems are constantly being improved, and new propulsion systems are tested. Studying the effects of long-duration space flights on astronauts is crucial for planning future missions to the Moon and Mars. But perhaps the most important aspect of the ISS is international cooperation. It stands as a testament to what humanity can achieve when countries work together in harmony. Living on the International Space Station is an experience like no other. Imagine waking up to a sunrise every 90 minutes. Picture yourself floating instead of walking. This is the daily reality for astronauts aboard the ISS. A typical day on the ISS is highly structured and demanding. Astronauts work 10-hour days during the week and half-days on Saturday. Their tasks are diverse and challenging, including conducting scientific experiments, maintaining the station's systems, and exercising to counteract the effects of microgravity. Life on the ISS is not without its challenges. Simple tasks like eating, sleeping, and even going to the bathroom require special adjustments. Despite these challenges, life on the ISS is filled with moments of awe and wonder. Astronauts often describe the profound experience of looking down at Earth and seeing its beauty and fragility. The camaraderie among the international crew is another rewarding aspect of life on the ISS. Chapter 5. A Heavenly Commute. Traveling to and from the ISS. Traveling to and from the ISS is complex and risky. It requires meticulous planning and advanced technology. The journey begins with a powerful rocket launch. Astronauts use the Russian Soyuz and the American SpaceX Crew Dragon. The Soyuz has been a reliable workhorse for many years. The trip takes about 6 hours and involves precise maneuvers. Docking is a critical and delicate procedure. Once docked, astronauts enter the ISS to begin their mission. Returning to Earth is equally challenging. The spacecraft undocks and begins its descent. Parachutes slow the spacecraft down. It splashes down in the ocean or lands on the ground. Chapter 6. A Beacon of Hope. The Legacy of the ISS. The International Space Station symbolizes human ingenuity, international collaboration, and the pursuit of scientific discoveries. For over 2 decades, this orbiting laboratory has served as a beacon of hope, inspiring generations to dream of a future among the stars. Its legacy is multifaceted, significantly enhancing our understanding of space, Earth, and ourselves. The ISS has enabled us to study our planet from a unique perspective, leading to advancements in environmental monitoring, weather forecasting, and disaster response. It has also been crucial in pushing the boundaries of human spaceflight, resulting in progress in medicine, materials, science, and other fields. Most importantly, the ISS has demonstrated that large-scale international cooperation is possible. Despite political differences on Earth, countries have come together to build and operate this incredible feat of engineering, showcasing the power of unity and shared ambition. The future of the ISS beyond the horizon. The International Space Station has been operational for over 2 decades. It stands as a testament to human ingenuity. The ISS is aging, and maintenance is becoming increasingly expensive. Currently, the plan is to keep the ISS operational until at least 2030. However, the ultimate fate of the ISS remains uncertain. Some propose repurposing it for commercial activities or future missions. Future stations will build on the legacy of the ISS and push the boundaries of human capability. Chapter 8. The Challenges of Space. Living and Working in Microgravity. Living and working in space presents astronauts with unique challenges. The microgravity environment, while fascinating, has profound effects on the human body. Astronauts experience muscle and bone loss, changes in cardiovascular function, and even alterations in their vision. Simple tasks like walking, eating, and even sleeping become complex maneuvers. Astronauts must learn to navigate their environment in 3 dimensions, using handrails and Velcro to secure themselves. To counteract these effects, astronauts exercise intensively for at least 2 hours a day, using special equipment designed for space. Another challenge is the psychological toll of living and working in a confined environment, isolated from loved ones and the familiar comforts of Earth. Astronauts undergo extensive psychological training to prepare for the mental demands of space travel, and they maintain regular contact with family and friends back home. Chapter 9. International Cooperation. A testament to human unity. The International Space Station is a shining example of international cooperation. It demonstrates what humanity can achieve when countries work together towards a common goal. The ISS is a truly global project involving more than 15 countries. The collaboration extends beyond the construction phase. The daily operation of the ISS requires continuous communication and coordination between control centers around the world. Teams from different countries work together to manage the station's systems, plan missions, and conduct scientific research. This international cooperation has not been without challenges. Language barriers, cultural differences, and political tensions have all posed obstacles. However, the shared goal of advancing space exploration has always transcended these differences, fostering a spirit of collaboration and mutual respect. Chapter 10: Scientific Progress. Discoveries from the ISS. The International Space Station serves as a unique platform for scientific research and exploration. The microgravity environment allows scientists to conduct experiments and make groundbreaking discoveries across a wide range of fields, from biology to physics. One significant area of progress is understanding the effects of space travel on the human body. Data collected from astronauts living on the ISS has provided valuable insights into muscle and bone loss, cardiovascular changes, and other physiological adaptations to microgravity. This research is crucial for developing countermeasures to mitigate the health risks of long-duration space flights, paving the way for future missions to the Moon, Mars, and beyond. Material science is another field that has greatly benefited from research conducted on the ISS. In the absence of gravity, materials behave differently, allowing scientists to study crystal growth, fluid dynamics, and the development of new alloys with improved properties. These discoveries have led to innovations in various industries, including medicine, electronics, and manufacturing, enhancing our everyday lives. The International Space Station, a stepping stone to the stars. The ISS is a testament to human ambition, ingenuity, and international collaboration. For over 2 decades, it has been a beacon of scientific discovery and global cooperation. The ISS has provided us with invaluable knowledge about living and working in space. It has fostered unity among nations and shown that together we can achieve extraordinary things. As the ISS approaches the end of its mission, its legacy will shape the future of space exploration. The lessons learned will pave the way for future missions to the Moon, Mars, and beyond.